Algebra 1 students, I've said lots of crazy things, but today we're going to factor special cases. There's absolutely nothing crazy about that. And at the end, when you figure this out, you can clap your hands and be happy. In section 8.5, we took a look at some special multiplication cases. Things like a plus b quantities squared, a minus b quantities squared, and a minus b times a plus b. The beauty of this is today we're just going to use those same patterns and work backward. So the big idea today is that some trinomials, those that fit the special patterns, can be factored by reversing special multiplication rules. And you can see the three right here that we'll be dealing with. So let's take a look at some examples of this. The first one we see is x squared plus 6x plus 9. Now there are a couple ways to do this. We could do it the way we're used to factoring, where we break it apart into an x and an x, and then I look and say, okay, well this sign right here is positive. That means these signs have to be the same. This is positive, so these both have to be pluses. Then we look at possibilities for 9. It's either 1 times 9 or 3 times 3, and of course we would choose 3 and 3. Okay, now I actually prefer a different way though. Let's look at it this way. X squared plus 6x plus 9 is in the pattern of a squared plus 2ab plus b squared, and that a would be equal to x and b would be equal to 3. So really all we have here is x plus 3 quantity squared. So again, if you recognize that pattern, you can save yourself a little time. Now number 2 is a very, very similar pattern, and honestly when I'm looking for that pattern, what I look for is this. I look at this term and this term. Now the first term is just x squared, perfect square, no big deal. The last term is 49, and when I see a 49, I'm immediately asking myself, are we going to use that 7 times 7 or 7 squared? Well, then I can go check the middle term. That's 2 times 7, 14, and we've got it. This, folks, is x plus 7 quantity squared. Now again, you could go back and factor like we did in the traditional method, just break it into two groups and go. But I kind of like this shorter method. I don't know about you. All right, let's take a look at another one here. Notice that we have a subtraction sign this time. That's something we have to keep in mind. X squared minus 12x plus 36. Again, we have a nice, lovely, perfect square, 36, which is 6 times 6 right there. And I could think of it as this way. It's in the form a squared minus 2ab plus b squared, where a would just be, in this case, our variable x, but b would be 6. And so what I have here is x minus 6 quantity squared. All right, we run into something new on number 4, and that is that our lead coefficient is something other than 1. But again, we have nice perfect squares. And we could do this format right here, a squared minus 2ab plus b squared. And in this case, you have to think a little bit, but a squared is 9x squared, so a would be 3x. That's because 3x times 3x would be 9x squared. B would be the square root of 25, or 5, because 5 times 5 is 25. And we've got it, 3x minus 5 quantity squared. It's beautiful what you can do when you figure out these patterns and how quickly they work. All right, the last slide. We're there, fast. X squared minus 144. Now this doesn't match the a squared plus or minus 2ab plus b squared, but notice that we have perfect squares, x squared and 144. Now I know you guys know 144 is 12 times 12. How do I know that? Well, because my 4th grade son is required to know that fact. I'm quite confident that my 9th and 10th graders can handle it. And so what we've got going on here, x squared minus 144, there's no middle term. How does that happen? Well, that's when we have the a squared minus b squared situation, which factors down to a plus b times a minus b. So this is x minus 12 times x plus 12. All right, last one we're going to look at here, number 6. And in this case, again, we have perfect squares. 16 is 4 times 4. X squared is x times x. 81 is 9 times 9. So right away, I can look at this and say, well, there's no middle term, so it must be a sum and difference of a binomial. And that would be 4x minus 9 times 4x plus 9. You'll notice that I've added 3 questions for you, 7, 8, and 9. In the margins or somewhere on your note page, I'd like you to try those 3. Look at the patterns. We've seen all 3 of these patterns. But answer those 3, and then take a look and see how your answers compare to mine. So pause the video now, hit play when you're finished with the 3. Alright, you can check your answers. If they're correct, you should be singing along, and you should be dancing, because we're happy. If you didn't get them right, that's right. You just clap along, you figure it out. We'll come back to class, and we'll get this taken care of. Until then, you guys have a great day. We'll see you.